Testing. Hello, hello. Think I should be live now. I should see it pop up here shortly. And I'm sure some people will be rolling in. As you roll in, feel free to say hello in the chat. Definitely makes it way more fun for me, but also probably for you to see like other people watching. Also, maybe put where you're streaming from. It's always fun to hear about where people are watching from. And then also, if you want to share more about why you're interested in building or learning about building pipelines for LLMs, that's always really fun too, to also see kind of what people are building. If you have projects in mind, or if you're actually working on something in production, it's always fun to hear a little bit more about the audience, and also helps me maybe cater some of the stuff that I'm going to be talking about too. I can maybe kind of talk about it towards your use case. Welcome, Ryan. Awesome, from Canada. I've never been to Alberta area. I've been to Vancouver and Toronto. And again, we'll be waiting a minute or maybe 2 minutes or so for people to kind of start joining in before we really get going into the presentation. But I'll share some links for you to get started right now too. So if you want to follow along, all these links are in the description. So also if you come back and are watching the recording, you can find them there as well. But if you want to follow along, the main things you're going to want to do is make sure you have a GitHub account, and you'll want to have a Google account, which probably most people already have. And then you'll want to sign up. We're going to be using this platform called Union. It's free to sign up. There's no card required. I think you get $30 of credits. We're going to use a very small fraction of that for fine tuning the LM today on the compute that's in there. So it's going to give us access to GPUs, but also a lot of the features around building production grade pipelines that we're going to be talking about. And then again, if you want to follow along, which hopefully most people do, here's the GitHub. You can go to that GitHub and it'll look like this. For the workshop, you'll just want to open up this open in collab link, or sorry, click on this open in collab link. And we're going to be running this today. So if you want to go ahead and start poking around in this, you're more than welcome to. You'll just already have to have a Union account here. And then also, I forgot to mention as well, you'll want to have a Hugging Face account, also free to create. We're going to be using this as part of our pipeline as well. And for people just joining, don't worry. I actually haven't even started yet. I'm just going through some pre-setup for people who were already here. But I'll mention all these links again as we get to them in the workshop. But like I mentioned, you want to create a Union account and a Hugging Face account. And then those will be really the accounts we need that you probably don't already have, or that you might not already have, to run the workshop today. And I see people rolling in. I think we'll wait about one more minute before we get going in the slides. But again, links to all the stuff is in the description. So if you want to follow along, which I hope that many people do, you can find all these links in the description. And then just go ahead and create those accounts. The sign up for Union can take about 3 to 5 minutes to process. And also, I'll note, if you have a new GitHub account, it might put you in a longer waiting time. And so if you just created your GitHub account like in the past month or so, you can let me know and I can try to forward it to someone to get it expedited for you. But other than that, it should just take like 3 minutes and you should get an approval email. And then, we'll go into the platform here in a few minutes. And I'm going to go through some slides first just to kind of make sure everyone's up to speed. And then we'll go in and do the hands-on workshop part. But again, if you want to kind of skip ahead and poke around, I know I like to do that sometimes. The links to everything is in the description below. But if it looks confusing, don't worry. I'll be walking through all of it as we go. And then just to give you kind of a quick preview, we're going to be building a pipeline that looks like this today. So we're going to fine tune a BERT model, which is a transformer model. You can kind of use the basics of this workflow and put in different models. We're going to be training a BERT model for classification, but you could use this with way more complex models and data sets. And part of the reason why we're using BERT today is because it's going to be quick for us to train to get a good example out of for the kind of limited amount of time. but you can bring in larger models and larger data sets. But what we're going to do is build a pipeline to download a data set, download the specific type of model. We're going to then train that model using the data set we downloaded. We're also going to visualize that data. Again, you could kind of combine these if you wanted to. I broke them out for a separate workflow or for a separate task. And then we're going to evaluate the model once it's done training. We're going to save that model. In this case, we're going to save it to Hugging Face, which if you haven't used Hugging Face before, it's a very popular platform. They also have a whole bunch of different very popular tools for transformers. In fact, we're going to be using a Hugging Face library for transformers today, but we're also going to be using the Hugging Face platform to move our model to. You can kind of think of it as GitHub for models and data. So we're going to save that there. And then we're going to have a separate task where we can kind of rerun on maybe outlier data. Like we can put in our own data and get predictions back and see what it says. So we can come up with some really fun phrases here to try to, trick our model or something like that and kind of see how it behaves here. And we're going to see kind of how to build this pipeline with some of the best practices in the field around like having containerization, scalability, versioning, all that's kind of baked in. We have really cool visualizations that are also embedded in the pipeline where, every time you run this, you get a different version. And so if you want to look at what that data set looks like for that version, you can embed any HTML here. So here's kind of a summary of the data. Again, we'll go through this as we actually get into it. I'm just giving a quick preview of what we're going to build. So we're going to fine tune an LLM, build a pipeline around all this, and you can rerun it very easily, which I'll show you how to do as well. So let's go ahead and get into the slides. I see a lot more people join. So again, links are in the description below for everything to follow along, but I'll also bring them up as we get to the areas where you might want to sign up or open notebooks as well. And so this is fine-tuning a BERT pipeline. Quick about me. My name is Sage Elliott. I work at Union.ai. I live in Seattle. I also run a book club that's really fun. So if you're interested about learning more about AI, we've been reading a new book every month. You can find me on LinkedIn or join the Slack channel. I also post about it in there. And previously, I've done a lot with computer vision, ML monitoring and evaluation, and a background in hardware and IoT, and a fair amount of MLOps in that field now as well. If you want to connect with me, I always love staying connected with people. You can join or find me on LinkedIn. You can message me there. I'm pretty active, but also there's a Slack channel you can join that is for the open source Flyte tool, which I'll talk about here in a second. But I'm also in there. And also it's just a great place to ask questions about anything we might cover today. Or if you want to stay connected with other individuals, there's a introduction channel there as well. So I saw more people join in. Quick about you. I saw Ryan, you already posted in the chat, which is awesome. Thank you. But if more people want to post in there, where are you watching from? What are you working on? And why are you interested in ML pipelines, or in this case, LLMs and fine-tuning LLMs? I think Ryan said you're just kind of more interested in learning how to fine-tune LLMs. Again, join the Slack channel if you want to ask more questions later. But during the workshop, ask questions in the chat, and I will be monitoring it as we go. So feel free to ask questions as we go, and I'll try to stop and catch up on them if I can. If it gets too noisy, I might accidentally miss your question, and that's okay. Just feel free to ask it again. Quick overview of what we're going to cover again today. So we're going to do a quick concept overview with some slides, and then we're going to set up Union serverless, which I had shared the account link or the sign up link earlier in the chat. But again, it's in the description if you're just joining. We're going to build a machine learning workflow. We're going to save models to Hugging Face Hub. And also, it's okay if this feels like fast pace or maybe a little challenging depending on your level of what you've worked with before in terms of like Python and machine learning. But you'll be able to run all the code and get everything done. So even if you feels a little over your head or something, I encourage you to stick with it and come back and pick apart the code and ask questions as we go. That's totally fine. And then for the workflow, again, we're going to be creating a container image. So it's going to be a very reproducible environment. We're going to download a data set, download model weights, process data, and visualize that data. We're going to fine tune a transformer model. We're going to evaluate that model, and then we're going to save a model to Hugging Face Hub. And then we'll actually look at a couple ways that we can use that model that we've trained to predict sentiment, and then maybe talk about what we could do further in production with that. And so this is actually kind of the core of a lot of ML pipelines that you might be building. So kind of a quick primer on like MLOps and LLMOps and ML pipelines. MLOps is a set of the best practices and kind of how you use those tools and libraries to deploy, monitor, and maintain the machine learning models in production. And I really like to stress the point of reliably and efficiently is really kind of what you want to do when you're building a good pipeline. Who's built a ML pipeline before, or maybe put a model in production? It's always interesting to hear about too, because um, you know, if you're going through a lot of courses, now it's kind of shifting. So it's kind of cool to see more MLOps best practices come earlier on. But a lot of times when you're going through a course, they would teach you how to fine tune a model. They don't even talk about data collection or data annotation sometimes. And then once you have that model and you evaluate that model, how do you put it in production and how do you do it at scale? This is kind of where MLOps comes in. So if you're building a basic ML machine learning pipeline, you're probably going to have some form of these steps, and you might have way more where you're going to be collecting data in some way. Again, you might have like data annotation as well. You're probably going to have pre-processing or exploring there as well. And then you have a train model. You're going to use that data to train your model. You're going to evaluate that model, make sure that it's kind of behaving the way you want before you put it in production. You're going to ship that model to production in some way. Again, that can really vary on your use case. Like, is it going to Amazon SageMaker, or are you deploying it to an edge device? Once it's in production, you usually want to have some form of monitoring. So there's a lot of really cool tools now that make this way easier. But if you're not using a tool to kind of monitor in real time or in batches like every day, you'd probably want to come up with a process of at least spot checking how is your machine learning model performing in production. Because once you put in production, data tends to change over time and it's not very reliable. So you want to make sure when that data shifts, your model either handles it correctly, or that you can maybe take that new variation of that data and retrain your model so it can handle it appropriately. And that's kind of where this improvement process comes in, where you're kind of building a lot of people call it like the data flywheel or ML flywheel or machine learning lifecycle, where you're kind of doing all these steps over and over again. Because once you have your model in production, you usually want to collect that production data in some way. Again, maybe annotate it and then kind of keep improving your model over time as it kind of degrades. Or some people will choose to do this like once a month or something like that. But usually now best practices are to use some form of monitoring, actually see how the model is performing, and then kind of rerun this whole life cycle. And there's a lot more. Again, this is kind of bare minimum. Again, there's probably more on processing data, prompt management now if you're doing LLMs, vector databases and embeddings, guardrails for your LLMs, A/B testing. There's a whole bunch of different stuff that can go into a really complex pipeline. So how you build a complex pipeline is you use all these really cool tools that do a lot of these tasks for you that we just talked about. Like I mentioned, monitoring. I used to work at a company called Y Labs that we specialize in that. This is their open source library Ylog. So you can kind of use all these libraries to do all those things that we talked about. And to make all that happen, you usually need some form of orchestration, or you're going to probably hear the term, I think, in the next couple of years, is people are going to be using unified AI orchestration or unified AI platform, where you're kind of bringing all these tools together and managing the compute that they run on to perform all those things that we talked about efficiently and reliably. So orchestration is at the core of most pipelines, especially at scale. So any big giant company like Google, Uber, Lyft, that are doing a lot of machine learning models, they have some form of AI orchestration or data orchestration going on behind the scenes. And actually, the platform we're going to use today, Union, is built on top of the open source platform called Flyte that came out of Lyft. And the creators of Flyte at Lyft now created the company Union around it. But yeah, so every company kind of, if you're doing this at scale, you have some orchestration platform that allows all these things that we talked about to happen reliably and efficient. So you want to think about scalability. How do you facilitate the scaling of your AI workloads to handle really large data sets and complex models? Reproducibility, you want to ensure that the workflows can be consistently reproduced. And that kind of helps with collaboration, transparency, between teams and people. And we're going to be using containers as part of that today. Flyte and Union is built on top of Kubernetes. So if you're familiar with Kubernetes, it spins up containers and runs those on different computes. So you can kind of scale this up as much as you want in your compute cluster. You want to have versioning built in where you can track data, code, prompts for LLMs and model versions, not just your code. Like you want to have usually all these things together. And in some fields, that's really important for compliance as well, like healthcare and financial models. You want to actually make sure sometimes you can track back why your model made those decisions. You want to improve efficiency, where you allow data scientists to focus more on, model development. So versus, infrastructure development. So we abstract a lot of that away with a good orchestration tool. And then also cost efficiency. We'll see actually how you can kind of think about this when we go through in the code. But there's a lot of ways you can optimize resource usage and reducing overall cost of paying for the compute, but also like your employees' time as well. And a few other things I'll quickly mention on the orchestration side, that when I see people adopt a really cool, like unified modern AI orchestration tool, some other things outside of the stuff that we'd think of that are kind of no-brainers, like versioning, scalability, things that people really, really enjoy that say they, save them a lot of time and or cost, is optimizing for local development and cloud development. So some pipeline tools you might have to develop, and every time you kind of, change a file and want to see how it behaves, you have to kick off a job where it runs in the cloud. With some other modern ones like Union, you can you can develop locally, mixed up those words, on like your powerful laptop, build a small pipeline, or build a pipeline maybe with a smaller model if you don't have the compute for it, test out how that pipeline works and behaves on data. And again, maybe it's a smaller sample size on your laptop. And then when you're ready to kick off that real training job, you can do so on the cloud environment. And then leveraging caching in pipelines. Again, this sounds maybe obvious, but maybe you haven't seen this before. A lot of times people want to rerun a whole workflow, but you might have these really costly tasks or time-consuming tasks, like pulling down a data set, processing the data. That could be really long and maybe compute expensive, depending if you had a really large data set. So if you're training a model, you want to change hyperparameters and see how it behaves over time. Instead of rewriting that whole workflow, you can cache those previous tasks and then just rerun the workflow, and then take the cache data in this case, and then see how your model behaves with different hyperparameters. A task level resource and containerization. So things built on top of Kubernetes kind of usually behave like this, but every single task in Union or Flyte, it runs in its own container. So again, we'll see this in action here very shortly. But you'll define a task that's a Python function, what it's going to do with the data or model. And then not only do you define the container image that it runs on, but you can actually define the exact compute that it runs on. So some older methods would be that you would run a workflow on the same compute cluster. That again, on training, that might include bringing in GPUs. But if you're running things like getting a data set that you don't need a GPU, you'd be spending that GPU time on those other really long tasks. So instead, this way you can define every single task, exactly the compute that you want to run on. And again, that can save a lot of money if you're paying for that compute, or it frees up GPUs if you're short on them. Mitigate errors with type safety. So Flyte and Union has built-in type safety. So when you're defining your Python functions or tasks, you have to define the input string and the output string. That can also save you some headaches on kind of runtime, finding out if you made an error or not. And then another one that a lot of people don't talk about is harnessing the economic benefits of spot instances and batch processing. So Union and Flyte also has ways where you can utilize spot instances from cloud providers. So if you've ever looked at AWS pricing, you might notice sometimes they have compute that they've already spun up. That's called a spot instance, where they haven't like sold it off yet, and they'd rather sell it for a much lower price. I think sometimes it's like 90%, but it's not always available. So if you can look for that, again, that can be a huge cost saver as well. All right, so today we're going to be using Union, as you might have already guessed, to run all these kind of things that we talked about. We'll see a lot of what we talked about in production, or hands-on with code here in a minute. But quick note is Union's built on top of Flyte, so you can check out Flyte here, which is the open source project, like I'd mentioned. Came out of Lyft. Again, the link is in the description, but I also shared in the chat here. And then also a quick caveat is Union's been out for quite some time and is a pretty mature product that a lot of companies use in production. Today, we're going to be using serverless, though, which is in beta. Serverless makes it really easy, so you don't have to set up your own compute cluster on any cloud provider. You can just log in and have compute available to you. And again, we'll see this in action here in a minute. But also just want to note it's in beta, so if you happen to see any bugs or anything like that, let us know, and hopefully we can fix them quickly. And also mention again, every single task here is containerized, so we're going to have inputs, outputs, and every single run of the workflow is versioned and strongly typed. Again, we'll see this in action here in a minute. And also, I'll just note, has a declarative infrastructure, so we kind of declare this in Python as we create our tasks. Built-in versioning, like I've said many times. Caching, type safety. It's super flexible, so it works with probably most of the machine learning libraries you're already using, but also has a really big plugin ecosystem. Has checkpointing, it's scalable. Like I mentioned, it's built on top of Kubernetes. And then also, we'll see, has a really nice user interface and a Python API that we can use. For the transformers, we'll be training a BERT model today. And I'll share the link to the paper here, too, if you want to go read more about it. BERT models were the first transformers that, at least from my perception, really brought kind of transformers to the limelight of people thought, oh, this is awesome and can really do something amazing, kind of before GPT models came out. And we'll be using transformers with the Hugging Face library, and we're going to fine tune it, which is we're going to pass data in. It's going to learn from that data, and then we'll be able to give it a new piece of data. It can make a prediction on it. And for saving and versioning models, we do have artifacts that are saved and versioned in Union and Flyte, but we'll also show how to move artifacts out, like a model in this case, to the Hugging Face hub, which is a really common part of building pipelines nowadays as well. Whether it's Hugging Face or somewhere else, just kind of show how to move a model to another area. That could be like for serving, or in this case, another area for versioning. Right, so let's get ready to build our pipeline. Hopefully people are ready now to run some hands-on code if you haven't already. This should take you to the notebook. And this is the sign up link if you haven't done so already. Sign up and make an account here. Again, there's no card or anything required. It might take 3 to 5 minutes to approve you. And then also go to Hugging Face and make a Hugging Face account here too. Ryan said he's ready. Awesome. Is anyone else ready? I see there's more people here than Ryan. Which, thank you for talking in the chat, Ryan. I'm going to wait 1 minute or a minute or so for people to open up those links, sign up if they haven't already. And if you go to that GitHub link, again, go ahead and hit this open in Colab. And then what I like to do is save a copy in my drive. This way, like if you change any variables or code here, you can always come back to it. Otherwise, if you don't save a copy in your drive, you can run it all here. But if you get disconnected from the instance or anything like that, you might have to update code if you were doing that or taking notes in here. So I like to save a copy in drive. I'm going to go ahead and do that. And now I have my copy, and I will zoom in actually a little bit if that helps people. Let me know if it should be more. I think this is good. Again, links to everything is up at the top here. And the only library we really need to install here is the Union library for our use case today. So you can go ahead and run this code cell by clicking play on it, or when it's highlighted, you can hit Shift Enter. So I will often hit Shift Enter, and then it's going to take a minute for this to install. And the reason why we only have to install this, one, Colab comes pre-installed with a whole bunch of libraries already for machine learning. Like I think it has PyTorch, TensorFlow. It might have transformers probably already installed as well. But the reason we really only need to install one here today is because we're actually going to run our full workflow today on the Union Cloud. So we actually don't have to install these locally unless you want to do local development. Like I mentioned, is a really cool feature where you could run this locally, make sure it's running before you kick it off to like a more expensive job in the cloud. In that case, you would need to install these. and then you could run a workflow locally, which I'll show you how to do later. But for our intense one with transformers, we're just going to do it remotely, so you don't need those libraries installed. So mine's already done. And don't worry about the errors here. I think it just says, there's some other, like I said, there's a whole bunch of other pre-installed libraries. And I think some of them says it's not compatible, but we're not using them. So don't worry about the errors. Everything should be good to go. And then once you're here, you can hit this Union create login serverless authentication device flow. So you can go ahead and run this. And you'll get this URL. You can click that. It brings up this page. Don't edit this code. It already is pre-populated with the authentication code for you. And now we should be activated here. So now we're activated in our Google Colab instance. So this is a whole kind of little Ubuntu instance running behind the scenes here. And now, as long as we don't disconnect, then we should be good to run all of our Union workflows here. So also, I'm just going to pause for a minute. And I know, Ryan, you're good to go. And it sounds like it's working. Great. Also, let me know if this doesn't. Just pausing again if anyone else wants to put in the chat if it's working, if you're ready, if you signed up, if you're waiting. Let me know what the status is. And I'm going to get a sip of coffee while I'm waiting. Kieran said, working. Awesome. Thank you. Great to know. All right. So we're going to go ahead and build our first really simple workflow. Just talking briefly about the building blocks of tasks and workflows in Flyte or in Union. And then we'll go and build our more complex one right after this. So also just quickly noting, there's this thing at the top of these files called write file. This isn't part of Union or Flyte. This is a built-in kind of magic function of Jupyter Notebooks, where all this code below that is going to be written to this Python file. So we're going to create a file called simpleworkflow.py. And that's because we have to create a Python file to then run our tasks here. So if you were working in notebooks, it's kind of a quick way to create this local file. And you don't have to do this, but if you want to explore that, you can hit this little folder icon, and we can see now we have this .py file, and I can even click on it, and I can see the contents of it. But you don't have to worry about it. You can just go ahead and run these code cells if you want. So we're importing a task and workflow from Flyte Kit. So if we go look at the pipeline that we're going to build is this, and every single one of these is a task. And then we define, what happens in this task, and also the like inputs and outputs of that task in that task. And then the flow of data between all these different tasks we define in workflow. So putting together the simplest pipeline basically that we can. We have one task here, said hello world. It takes in a name, a variable called name that has to be a string, and it's going to output a string, which is just combining hello with that name. And then our workflow is just running that task and passing in the name, and it's going to return a string. So again, this is really simple. Right below, we're going to be building that more complex one here. Now that we have this as a .py file, we can run this locally. We're saying union run, and then we call that Python file. Then we call the workflow name, which in this case is main. And then we're going to pass in a string, which I'm saying Flyte. You could change this to your name, anything you want. And we're going to run it. And then this is running locally now, just in the instance on Google Colab. And it said hello Flyte. Now we can run this on the remote cluster in Union by just adding this remote tag. So we're going to run the same thing just for that remote tag. And it says running execution on remote. I should just take a second here to output a URL. Now you can click on this. And we have this list, which is just one thing right now, of our task. If you go to this graph view, this is the view that I've been using to show the longer workflow. We can see we have this container running. Mine's already finished now, but it has to spin up a container here. So it might seem like it takes a little bit longer than just running it locally, because that's to spin up a container and then pass in the variable that we gave it. And then the output here is hello Flyte. So now we can see that we've run this task on this remote cluster that can scale up. And again, we'll be building the more advanced one here in a second. But if you want to relaunch it, you can as well, just hitting this relaunch button. So we'll see this when we build our model, but you can imagine this is a really nice UI. Like if you're training models and you want to input different data sets, different model types, actually potentially, and hyperparameters. Now you have this like UI that has this scalable compute that you can kind of rerun your models on really easily, right from the UI or from a Python API, which I'll show you how to do towards the end of the workshop too. After we train a model, we'll see how to like pull in this information just in Python as well. So pass in a different variable here. I'll say workshop attendee and relaunch that. Now we have a new version of our workshop too. Like I mentioned, these are all versioned. You get a snapshot of the code, all the artifacts coming out of here. We can also see it's related to this original one. So I can click on this and it would bring me back to that original task. And then we can look at our input, output, and it says, hello, workshop attendee. So again, this is like the simplest workflow that we can build. If you ever want to look at more options of what you can call while running a workflow, you can you can add this help tag, and it tells you the inputs and which ones are like required or not. This one, if you just do all the or have the help tag on run, tell you all these other options you can add in. So I guess I should also note real quick in the Union UI, if you hit this little icon here, it brings you to the home page, and you'll see, I think yours might have 2 projects by default, which is Flyte, Snacks, and Systems. But you can build different projects and organize your workflows in different ways. You also have for each of those projects default, staging, and production. So by default, when we run it in serverless, it's going to run in Flyte Snacks, which is kind of like your experimental zone, and it's going to do it on development. But you can say like, I want this to run in this project folder under staging. There's also a lot more you can do with workflows and registration and scheduling. Today, we're just kind of running the workflows, but there's a lot more to kind of dive into if you want to in the documentation. Right, so we made our super simple workflow. And for the 2 people talking in the chat, and for people who maybe haven't talked yet, did that work? Did that run? If that ran and you were able to get into the UI and see everything should probably go smoothly for the rest of the workshop for you. And for anyone just joining, it's still not too late. We're fairly early on into the notebook. So you can also join and open up the GitHub, hit that collab button. And if you hadn't, you can sign up. Awesome. Ryan said everything is working. Fantastic. All right. So now let's go ahead and build our more complex workflow. Again, we're going to create a container image because when we ran the other previous workflow, it just ran a default container that just has like Python. But we want to create a container image with the specific versions of everything that we're going to use. So including like Hugging Face transformers, etc. Again, we're going to download a data set, download pre-trained BERT model. We're going to visualize the data set, fine-tune the model, evaluate the model, save the model to Hugging Face Hub, and then also show how we can use that new model for some inference. One thing we have to do if you want to save the model to Hugging Face Hub is get a authentication token from them. So if you have your Hugging Face account, which again should be very quick to sign up for if you haven't. Also, I think to get your authentication token, you might have to verify your email. So if you just created your account right now, you should probably get an email from Hugging Face, and then I think you verify your email. Otherwise, I think the creating access token button might be grayed out. So let's go to, you can hit your little profile picture here, go to settings, go to access tokens, and you want to create a new token. So again, if this button is grayed out, it might mean you need to verify your email. Otherwise, you can hit create token, give it a token name. You could just call this like Union Workshop if you wanted. And then what we need is write access so that we can save the model to this to a space in your Hugging Face account. So you can just click write access to contents. By default, it's also going to make it read. So this can read and write data to a repository that you're going to have here. Once you click that, scroll down, hit create token, and you'll get a token like this. Copy that over. go back to your notebook, run this code cell that says union create secret, and paste that in, and then hit enter. If you're on dark mode, it's kind of hard to tell that that is a text box, but you can click on it, paste it in, and then hit enter. And I don't want to save that. For me, it threw an error. The reason is because I already have that token saved, or a token with the same name called HF token, but yours should not have thrown an error. And if I run union get secret, I can see that it pulls in. Here are all my secret names. I have my Hugging Face token, OpenAI, etc. And I'm going to actually go ahead and delete this one since you all saw it. Go ahead and delete it. Did anyone have any questions on that? Or was it were you able to get your token? Once you get that, then we really should be set up everywhere and easily run all the code. And if you didn't have a Hugging Face account already, it's a really cool place. They have a lot of cool features, like I mentioned, libraries like transformers, like we're going to use. Also, they have something called Spaces, where you can host a little ML application or some sort of application on their compute. Actually, if we have time at the end of the workshop, we can maybe poke around at that a little bit too, if people are interested. All right, so no one said yes, but no one said no that they got the token. So I'm going to keep going unless someone wants me to cover that again. Feel free to ask me to come back and go through something again too. So awesome. Kieran said yes. What I'm going to do for this next one, we're going to come back and read through all this code. But before we do that, what I want you to do, because the first time that you run this and have to create a container image, it can take a few minutes. So go ahead and hit run on this. And again, it's going to create a Python file here called BERT finetune.py. So go ahead and hit run. And again, I'll come back to this code here, but I want you to get running and building the container so that we don't have to wait more time. So you could just run this next code cell, and this is going to run this BERT finetune.py workflow on the compute. If you can, and it's okay the first time if you run it, if you don't have this in there, it's fine. It'll just fail uploading. But if you can type in your Hugging Face username, so mine is Sage Codes, and then give it any repo ID. So it doesn't have to be an existing one. You can just create one here and it'll create the repo as it runs. So I'm going to call mine LM repo, but you can call this anything you want. And then go ahead and run this code cell. And so you'll see for me, it's going to say a container image found, and it's not going to have to build it. And it's going to start running the execution. But for you, it'll probably say, oh, no container image found. Let's go ahead and build that container. So it might take several more minutes for you, and that's okay. So here, yep, image found. So it's actually going to go ahead and start kicking off my pipeline. But again, yours will have to first build the container image that it's going to run in. We'll see how it builds that here in a second, or see why it's going to build that. So I'm going to go back to my code. Again, if you run this without the name here, that's fine too. It'll still build the image and everything. It'll just fail later on when it tries to upload the model to the pipeline. But you can come back and adjust this later. The main thing is just run this, so it'll go ahead and build your container image, and we won't have to wait for it when we get to that point. So I'm going to walk through this code. I'm going to try to go fairly fast, but kind of explain everything. And feel free to, point me back somewhere if you have questions. And I might go maybe a little high level on some stuff too. Again, just feel free to ask questions in the chat. So we're going to create all these tasks here, and then define a workflow of how we want them to behave. So first, we're going to import all the libraries we need. I'll just talk about these, I think, as we use them. But you'll see there's some from like Flyte Kit, which is the Python SDK around Flyte and Union. We have this called image spec. This is actually what creates the container image for us here. So instead of writing a Docker file like you might have done before if you use Docker, which is the most popular container image creation tool, instead we can define what we want in our container images here right in the Python code with image spec from Flyte. And in this case, we're just defining the Python packages we want. But you can add way more here. Like you can add apt-get, you can add CUDA versions, stuff like that. For us today, we're just going to say we want our container to contain these specific versions of these libraries. And then we assign that to a variable. And then for each task, we can point the container image to that variable. So you could have different containers for different tasks. Today, we just have this one container, but you could have different one for different tasks if you want. So now we get to our first task, which is downloading the data set. And we know it's a task because this decorator at task, like we saw before with our very simple workflow. But instead of just leaving it blank, we're actually passing in some declarative things here. Like we mentioned, declarative infrastructure. Now we can do that right in our task decorator here. One, we define the container in which we want this task to run in, because we'd mentioned every single task is containerized. And then we're going to use something called caching for this data set one. We had mentioned in the slides, if you're here for that, about how, if you're rerunning a workflow, you probably don't want to do every single task every time, or maybe you do in some cases, but for downloading a data set, you only want to do that if you have new data, probably. Otherwise, it could be pretty costly or could be a lot of time. So we're going to say true. You can give that cache a version as well. And then we're going to request resources. So we're going to say for this task, we want 2 CPUs and 2 gigabytes of memory. If you have a more intensive task, this is where you could up the CPU, up the memory. And also we'll see later on when training our model, we'll actually request a GPU as well. And you can also request specific accelerator types. So in serverless, like we're using today, I think we have 3 GPU types. I could be getting these wrong. I think L4 and 2 and T4s from NVIDIA, and then also NVIDIA A100s as well. And then we define our task, which is just a Python function, except for, remember, we have to be strongly typed. So we're saying it expects to be a Flyte directory is going to be the output. And a Flyte directory is a specific thing in Flyte and in Union, where because these tasks are containerized, like we had mentioned, and the data that occurs in them, like if you create a local variable or download a data set in this case, that isn't inherently passable to other containers because that container will then spin down. So you can create something called a Flyte directory or a Flyte file, which will reference that piece of data and then actually save it to like a blob store. So we're going to create a Flyte directory out of our data set that we're going to download. We're going to get that path with this current context method in the working directory. And then we're going to basically create a directory for the cache when we download. And then in load dataset, which is a function from Hugging Face, where we're going to pass in the IMDb dataset. And we'll see a preview of what this IMDb dataset looks like, but it's a whole bunch of reviews of positive and negative movies or movie reviews. And we're going to fine tune our LM on that dataset. You can pass in a dataset or cache directory, which is where our basically our Flyte directory is going to point to now. So when we reload this data set, we can basically point it to this dataset cache directory that will persist outside of the container, and then it can more quickly load in that data. And then we're going to download our model. So same thing as above in our task here, we're enabling caching. So if we rerun this workflow, we don't re-download the model. We're going to use the same amount of CPUs and memory. By default, if you don't request resources, I think it's 1 CPU and 1 gigabyte. And you can change that, though, if you're using like Flyte or Union, bring your own compute, which is the more like enterprise version. And you can set up like what the default is for your tasks. And then we're going to download the model. Again, it's going to be a Flyte directory from Transformers, which is the model from Hugging Face, where a lot of great transformer models live and all these other really cool features around them. If you haven't used it yet, you probably will in the future if you're getting into large language models. We're going to port auto tokenizer and auto model for sequence classification. Again, we're getting a working directory from our container and the path where we're going to save that model cache to. And then we're getting a pre-trained model, which we're going to pass in a string when we run this that is going to be BERT uncased. And then it's going to, again, save that model to this cache directory, which then becomes a Flyte directory. And then we can reference it later when we pull in a model in another task. And then it should, load in this pre-trained weights faster. And yeah, we return that Flyte directory. And then we have this task called visualize data. And this is where I think it's easier if I show you what we're going to build and then show you the code around it. So I can just visualize data task here. I can click on this button that isn't always just by default on in other tasks called Flyte deck. So we can enable something called a deck, which allows us to embed HTML and complicated visualizations and like anything we really want to embed there as HTML. And in this case, I have kind of a little data analysis on our data set, and it tells me information around the training data and the testing data. So you see here the shape is 25,000 rows. We have text and label. So it's like the movie review, the label, if it's negative or positive, and then the label distribution, which in this case is, I think, just evenly split between them. And then here's an example of reviews from the training data set. So here's a positive review about a movie. And then here's a negative review. So you can see these are quite long. And then we even embed a chart here that shows the distribution, which might be a little bit overkill for our evenly distributed clean data set today. But if you have more complex data and you want to see distribution or pair plots or any other type of visualization that would be helpful for you to understand how your model's learning, you can embed that here. And then we do the same thing for a test data set. Again, evenly distributed between all of them, but we have examples here. So kind of cool to log everything in your workflow of like the data that was being used here. So in our task here, visualize data, we import some other libraries. We set the current context. Again, this kind of sets the like the directory of everything in our container. And then here we are going to load in that data set from our cache directory. We're going to split it or create two data frames, train and test data frame. We're going to create a deck. So when we do this, we can give it a title, and that's going to be the tab that, let me open this up again, the tab here. So you create multiple decks too, if you wanted to, not just a single one. And then we're going to get samples from the negative and positive for train and test. And then we're going to create those visualizations with matplotlib. And then we have a function that just converts the images to base 64. So it can be embedded directly in to the HTML there. And then here, this is just an HTML report that you can use like all the paragraph tags, H3 tags, if you're familiar with HTML, directly in that report and make it as pretty as you wanted. We didn't really do anything crazy with ours, but you can. And then we just append that HTML report to the deck. And in this case, we're just inserting it into slot 0, which is the first tab, but you could also, insert it into different tabs and make a really complex report with a whole bunch of different tabs there. So that created our data evaluation task. And then here we go on to our train model task. Here, the only thing that's different in our task is we're not enabling caching because every time we run a workflow, we probably want to train our model in this case. We upped our resources. We have one GPU. I actually upped the CPU and memory here too, I think because I was originally working on another task too from machine learning model without a GPU. So actually, since we're running on the GPU, we probably don't need all these extra CPUs and gigabytes of memory. So we could actually downgrade this. But so if you wanted to, I think you could run this on 1 or 2 gigabytes of memory. Maybe you get in there, but actually we'll look and see when we run this of how we can tell how much resource this task actually used, and then maybe come back and adjust for it. So a lot of times people will build a pipeline in production. They put these numbers here like I did, and then they never change it, even if they're not using all these other resources. So maybe I put 2 GPUs, but my model really runs fine on 1. And I put 12 gigabytes of memory. Maybe it was, it could have been way more costly than this, or I could add like 8 CPUs. But we'll actually see how we can see for each task the resources that it consumed. And then you could come back and edit this down. So you could start with this higher one and then make it cheaper and do cost optimization by kind of paring down the compute to really what you only need. So here we're going to train our model function. Takes in a model name, which is a string, the Flyte directories that we created. By default, it's going to run for 3 epochs, which is like looking at the data set 3 times, adjusting values on it. We'll see we can pass this variable in through the UI or Python API when we call this. And then it's going to return a BERT sequence classifier model. So again, from we're just importing like the dataset library again and the things for transformers like we did before. We did this in each task here. We actually could just put the imports at the top as well if you're okay loading that in for each container, which is probably okay in our case. But if you do want to optimize more, you can just do it per container here. Setting current context again to save like a local directory inside our task, which is going to be under models. And then we take in that data set, load in from that dataset cache directory that we had created before. We're going to load in that model from the cache directory that we had downloaded before, which is that BERT sequence model in our case. And then we're going to say the number of labels is 2. In this case, just positive and negative. But if your data set has 3 different labels, you would adjust this. And then this is a pretty common thing that you'll see in like the transformers models here, where you have this dictionary of ID to label and label to ID. So it knows 0 equals negative, and the word negative is equal to 0. And then it's also going to read in from that model cache directory again. We have a tokenizer function, which if you're not familiar with tokens yet in LLMs, that's kind of a way of chunking up text. There's different ways you can play around with this. Basically, it's not always a single letter or a single word. It can be different ways of doing that. And there's a whole fun field and rabbit hole you can go down in tokenization right now about like changing the tokenizers can really change how LLMs behave. I think it was Andrew Kaparthi did a really interesting talk on that with changing tokenization for like better coding. Like I think one of the reasons LLMs weren't good at coding before was the way that they were tokenized. And then we're going to read in just a small batch for our example today. You can up this if you want. So it's just going to read in the 500 examples from the training data set and 100 examples from the test data set. But we saw before there's like 25,000, I think, in the training, or sorry, in I think it's 50,000, 25,000 of each label. So you could up this just for today for our training example. So it doesn't take forever for us to train. We're going to use a subset. But again, you could up this if you want, or use the whole training data set if you want to edit the code. And then we're going to compute some metrics about our model as it trains, which is like accuracy. And then we're going to pass in those training arguments that we defined above. The training directory, it's going to evaluate every epoch, so every cycle. It'll kind of get the accuracy from it. And then we're using this built-in thing in Hugging Face called trainer. So it makes it really easy. It's a big abstraction on training a model. We pass in the model those training arguments that we created, the data set, the evaluation data set, the compute metrics, and then we just call trainer.train. And it's going to run on our data for 3 epochs, and then give us that model and some evaluation results. And then we can take that model, run it in our evaluation task, which again, we're enabling deck to true again to get the Flyte deck, so we can log evaluation data there if we want. And then we have to bring in a GPU again because we're running that model on an evaluation data set, and we need GPU to kind of run that model again. We actually probably don't need this 12 gigabytes memory, and we can maybe look at that as well in the UI when we actually run this. So we have our evaluate Python function or task here, and it's going to return a dictionary, takes in the model, the dataset cache, the model directory cache. And then again, just like we did before, we're loading in the data, loading in the model. We have our tokenizing function, and then we're computing metrics. Like in this case, we're getting accuracy, F1 score, precision, and recall, kind of all the classic classification metrics that you might want. And also, I just saw like there's a whole chunk of people who joined, it looked like. If you want to follow along, everything is in the description below. So if you do want to catch up and like quickly run through the notebook or something like that, all the links are in the description. All right, and then we initialize the trainer for evaluation. So it actually just runs and gives us predictions versus training. And then we have our save model task. We're almost done. We only have a couple more tasks. And and then we'll actually look at this running. Let's see. Oh, the only thing that's different in this one is in this task, we're specifically passing in a secret, which is our Hugging Face token, HF token. So make sure that you enter this the same way as you entered it, which I think it should be the HF underscore token. If you happen to put dash or something like that, make sure you change it here. But this is going to access the token that is saved in Union now. And so we have our save model. It takes in our model. It takes in a name for the repo, which is that string we pass when we call it. It initializes, again, the current context here. So we're going to basically save the model to a directory called model. And then we're going to ensure that these two things exist that we're looking for our model in this case, which is model.savetensors, and then a configuration.json for that model. It's going to look and make sure each of those exist. Oh, I left this in for debugging. I think that just prints out that they are there, because I think I ran into an issue at some point with it. And then here, we're getting our Hugging Face token if it's in a .env. So if you're doing this on local development, the other thing you would have to do is create a .env file, just make this token there, and then it would read it in. So look for that first, because I was doing local development with this when I was creating it. And then if it's not there, it's going to go ahead and pull in that token that we passed in that's saved on Union. And that's going to say which one it's using. And then here we're initializing the Hugging Face API. And we're going to create a repo with that repo name. And we're saying exist OK is equal to true. So if that repo already exists, it's going to overwrite it, which is fine in our case here today, but you can change this to false, or I think by default it's false. And then for both of those items, we're going to go through and call this API.upload, which is going to take in the path for the object, which in this case, like it's that save tensors and config.json. And then this path and repo is going to be the name you want it to be in the repo. I'm just going to call it the same, both whatever the file path is for each one. So when we go look at our repo later, they'll have the same name. Repo name, again, that could be anything you want. I called mine LLM repo when I called it. And then just going to give a commit message to it, uploaded file name. Repo type is set to none. By default, you can just save any type of data in there. But they have special types for data sets as well. So if you wanted to, you can use this API to create data sets. And then we have this one more task, which is predict sentiment. This is kind of the extra task I like to throw on sometimes when I'm training a model to, in my pipeline, I can kind of quickly assess maybe how the model behaves on different types of data that I think might be out of bounds or very different than the training and evaluation data set. So sometimes I like to throw in like an extra task like this. So I can call it kind of in line with my workflow. And we'll also see how we can just rerun this task and even potentially use it for batch predictions if we wanted to. It just loads in the model and then takes in text that we're going to pass it when we call it and just return a prediction on it. Now we get to a workflow. So I know this is maybe a lot for everyone. Now we have all these tasks defined. We want to kind of put them together and define how data flows through them and how they're all connected, just like we see here. And we do this with the workflow decorator like we saw before in our very simple one, except for this time we're tying a whole bunch of tasks together. So our workflow is going to take in a string, which by default is going to be BERT-based uncase, which is the type of model. It's going to be the model name, which is my model, but you could overwrite this as well. By default, the test text that we're going to send into the extra prediction function is going to say, I love this movie, but we could, again, put a more complex text there and see how it behaves. By default, it's going to train on the data set 3 times, and it's going to return a BERT model and a Flyte directory and a dictionary of the evaluation metrics. So here is our first task, which is download data. This is the first one we defined, and we're pulling out the data set cache directory. Then we have our download model. We pull out our model cache directory. We have that visualize data task. Then we have our model, which expects the model name, which we're going to provide to when we run this, the data set cache, the model cache, the number of epochs. Then we have our evaluate model, which is going to return the evaluation metrics that we defined. And then we have the save model that expects the model to come in and the repo name that we want to save it to. And then we have that one last little extra prediction function. We're going to predict sentiment. We're going to pass in that model, any test text that we want, and that model cache where it should live. And then we're going to return the model cache, evaluation results, and prediction. So again, that was a lot maybe. If you didn't already, you can hit Shift Enter or the play button on this code cell. That now created your BERT finetune.py. And then you should have already hit this before if you were here earlier, and it should have built your container. So if you didn't already run this before, type in your Hugging Face username and then any name you want for the repo here, and I'll create that repo and then hit run, and you'll get a URL like this. Go to it, and then you'll see it running. In my case, it's already done running, but you'll see kind of some status here on all these things. And then now we have our workflow where, again, we had already kind of looked at this previously. Again, I saw a chunk of people come in. So if you want to follow along, we're kind of towards the end, but you can go grab the notebook and run all the code. All you need to do is set up the Union account and pull up the GitHub notebook. And I'll share those links one more time in the chat, but they are all in the description as well. If you want to sign up, again, no card required. And then this is the GitHub repo. Just hit that open in Colab notebook if you want to run along. And I'll be sticking around for a little bit if you want to ask any questions as well. So we most people, we already saw, like, we had this visualized data set with our Flyte deck that we had created. And then we had our evaluate, which I did create a Flyte deck, but I actually didn't create a good visualization here. So I just logged stuff in an output tab here. So you can see the evaluation loss, the accuracy of our model just on 3 epochs with that small data set is 86%, which seems pretty good. Again, you could do way more epochs. You could also pass in way more of the data set versus the small sample that we did. And you can also see the outputs logged here. And then if we look at save model, you can see it uploaded to the repo that I gave it. And the predict sentiment, again, remember, when I ran it, we passed in this by default. It says, I love this movie. Obviously, predict positive on that, and it gave us a 99% positive. If you go to your Hugging Face account now, and just go to your profile, scroll down, you should have a repo that looks like this. And mine's called LLM repo. Yours is called whatever you passed in. If I go to files and versions, you'll actually see now I have my model file and my config file for my model saved here. Now I could pull this down basically from to any other machine and run this or deploy it. And now I have a version here. And every time I run my workflow, and if the model's different than it was before, it'll upload the model here. So every time we run that workflow now, if you're experimenting with different hyperparameters like number of epochs or data, well, the data will be logged in Union. But in this case, we're just passing the model here. So any variation of model, you'll get committed here. And then you can actually go back and look at different commit histories. And so you have a version of this, which is awesome. Any questions? And I went through a lot. I talked a lot. There's a little bit more I'll get through in the notebook. But we went through, and if you've never fine-tuned an LLM before, you fine-tuned one now. So you fine-tuned a large language model, and you saw a preview of it working here with that predict sentiment and the evaluation metrics here. Not only did you fine-tune a model, but you also did it with like a state-of-the-art pipeline, which is really cool. So if you've never really built a ML pipeline or MLOps pipeline, hopefully this is like a really fun introduction to it. And obviously there's a lot more that you can go in here. Like I talked about ML monitoring, building more of that feedback loop into your workflow. But what did you think so far? Was it interesting? Did it feel easy? Did it feel hard? Does it seem like an interesting tool? One thing I'll mention too, like in Flyte deck, and this is all saved anyway if you don't have the Flyte deck, but you can see like the specific version of your source code per task too. To kind of visualize, like, get a snapshot of your whole pipeline, the artifacts, the source code for each version every time you run this. So you could relaunch this whole workflow from the UI if you wanted as well. So again, we talked about using this like to experiment different models or experiment with different hyperparameters. I'm not going to rerun right now, but you could type in, I want to run this for 10 epochs and see how it performs. You can just relaunch it from the UI. You can also relaunch individual tasks from the UI. So here, I am just going to launch this predict sentiment task. So I'm gonna hit relaunch, and from the UI, you see by default it has the passed in model and stuff like that. And then I'm gonna give it a different text. So I'll say I hate this movie. Again, we can try some longer form text here, and I'll hit launch. And now instead of the whole workflow, I just have this single task running with that trained model. And again, this is a good way to this is kind of example of you could use just a task here for batch predictions as well. Again, it takes a minute to kind of spin up the container. So right now we're working on some other features around faster serving. But for now, this is actually a popular way that companies use for batch predictions, where it's okay if it takes a minute to spin up a container, and you can pass through, a whole bunch of documents. Like in this case, for movie reviews, you could pass in hundreds of movie reviews and get their classification, and then just return that back to you. And you're okay, waiting that minute for the container to spin up. But if you're doing that, I'd actually probably make another workflow for inference. But you can use just a single task that was in another workflow if you wanted. So we'll see. This will take just a minute here. Someone said they got an error, a system traceback, most recent call. Is it potentially because you didn't put in the right Hugging Face username? Someone said their container build, but the tasks are failed. One of the best ways to probably help debug is, because you can't share images in the chat here. One, if you can share more of the error messages, that would be good. But if you go to the Slack channel that is linked in the description, let me make sure I have a channel for you to post in. Let me just create one real quick. So it sounds like both of you are having errors. I created a channel in the Flyte Slack called Workshops. And if you want to post an image in there, that'd be great. Or more of your traceback. Someone said Hugging Face username. I know, because I've gotten that error before where I typed in my username wrong, even even though I've done it a whole bunch of times, and I was like, oh, what's going on? And it turned out that I had the wrong username here. But Kieran, it sounds like your multiple tasks are failing potentially. Did any of them succeed, or is it maybe the potentially same thing with adding in the variable? Also, while people are getting that information, I also forgot to show. So back in our workflow here, we can go look at our trained model, and we can actually view the utilization of the compute for this. And so, like I had said, I had left in some longer compute, or sorry, larger compute than I needed. So we can actually see that this yellow bar is the allocated amount, and then the amount used. So actually, we could just easily downgrade that from 12 gigabytes memory to 2 gigabytes of memory. And same with the CPUs. We just used one because we had the GPU that we're actually training our model on. And so it did use our one GPU, but we could have downgraded from 4 CPUs to 1 CPU. And again, this is something that we'll commonly see, like people with production pipelines, like they define compute once and then kind of just forget about it. But you can easily come back and look at the utilization of each task and then bring this down to where it needs to be, which again, in this case, probably wouldn't cost too much. But over time, if you are running a lot, it would. And then if you have something with way more utilization than you're using, it's a great way to bring down costs as well. All right, so let's see. My prediction task is still running. It's still spinning up the container. Someone said download dataset failed. It's showing caching disabled for this execution. The first time when it downloads, that should be okay, or it should show caching was disabled probably for the first time, and then when you rerun it, it should be cached. Let me go back to my workflow. So for me, it'll say output for this execution was read from cache. The first time we run it, should it be similar but with a little checkbox? And I don't know. It'd be good if, again, if you join the Slack channel and maybe add more to your traceback or image, or potentially Hugging Face is down. Yeah, if you could share actually just in the chat here, even what the error message looks like. So if you do go in, if you have an error in one of your tasks, you can go to it, scroll to the one with an error, and then there'll be this show error button here. And this will actually give the traceback that should be the error right in the UI, which is also a nice feature. Actually, you don't have to dig around too much. Oh, you reran the workflow and it's running now. Interesting. Yeah, let me know how it goes. I don't know, but maybe we can go look and see if I know I've had this once before. Hugging Face is very stable, but I have had it happen once before where it didn't download for some reason from Hugging Face because we're pulling in a data set from them. But if it gives you an error again, go to that task and hit this show error. And then if you could copy, even though it'll probably look ugly in the chat here, if you can copy that error message in, that'd be great. While you're doing that, I'm going to go ahead and quickly go through the rest of the notebook. There's just a tiny bit more. We went ahead and built our pipeline, which is great. Here, though, and we interacted with the UI and saw how we could rerun a task and everything in here and access the model. But we can also do all those things through the Python API. So we're going to import Union Remote. And then we're going to get our most recent executions that have this name, BERT fine tune. So I limited it to 10. You probably just have 1 or 2 if you reran it. For me, I've run it several times. So I had a whole bunch, and I just limited to the first 10. And then out of those executions, we can see here's a whole list of them. I want to go ahead and just grab the latest one. So I'm going to get the execution of ID 0. And it actually gives me a version name here. And if I wanted to, I can go ahead and even go back to my executions, look here, and even make sure that that is the correct task workflow that I want to reference. And then I'm going to fetch the recent executions. And we can see that, again, this is just information about what folder it lives in, etc. And then out of that execution output, I can see that these were the outputs that our workflow had. So the precision dictionary or evaluation dictionary, the actual model path, the prediction score for the text that we passed in. Now I want to grab just the model file and the model cache, and then I can rerun this model from the Python API here. And I want to get that predict sentiment task again. So I'm just calling fetch task. It's bringing in that one that we ran before. And then I'm just going to create a little dictionary of inputs that's going to say text. This is the text that we have in. I'm passing in a little bit more of a complex thing this time, saying instead of just I love or hate this movie, I'm saying why did this have 40 minutes of farming wheat, which could be, kind of ambiguous. Like, do you like farming wheat? Is that negative or positive thing? And then we're going to execute that prediction task with these new inputs. And in this case, I ran it where I'm not calling wait equal true. So this is going to give us this execution URL, and we can go look at it in the UI just like we did before. But if you wanted to, and we'll actually see an example below if you want to stick around, we can add this wait equal true, and then I'll just kind of sit there until it's executed and then return the outputs. Once that's done running, we can call this a remote.sync execution, and I'll go back and get the current state of that execution, which then will contain outputs. Currently, they're not in there. Actually, if I try to run this currently, it'll yell at me because it says, there are no outputs in there right now. So then once it's done running, which it is now, and if we clicked in here, we can actually see that it predicted that the farming wheat was negative, pretty high confidence there. And then I can call remote sync on the execution again. And now I can pull in the outputs and actually pull that down. And this seems like kind of a interesting way of doing it, potentially. Like we're basically referencing previously executed tasks, and then we're pulling data out of them, just like we're returning data out of functions. And it does work. There is a better way to do this that's built into Union called artifacts. And I'll share a link here. So instead of kind of calling specific executions and getting the data like out of a function, you can define those artifacts to to an actual structure called artifacts that we can reference way easier across different tasks, which makes it easier to call like specific versions of the models, data sets, and with it, see, do I have any in my environment? With it, you also get data lineage. So when you have an artifact, like in this case, it's a vector store I used, I can actually see every single like workflow that I used it in and what happened to it, which is pretty neat. So just quickly mentioning, there's a better way to kind of probably organize your data and model artifacts that we didn't use today that's built into Union. All the stuff we did today, though, you can also use in Flyte. So if you did want to set up the open source Flyte cluster and not use Union here, you could do that. Artifacts is a Union feature that makes it easier to organize your data. This is kind of a bonus thing. So I'm going to come back and look for questions. Actually, also, I know we're a little over time, so I'll stick around and help troubleshoot if people are still having issues. But I will also mention there's some other resources down at the bottom here. So if you want to look at how to build a RAG in a similar fashion with a pipeline like this, having the versioning, I think that one actually uses artifacts like we talked about as well. Also, if you want to look at how to use A100, so maybe you're training a much more complex large language model, those are available in Union as well. You can just define the accelerator type in your task, like kind of like we saw before, we're referencing a GPU, but you're actually putting a specific accelerator type. And you can see there's a lot of cool use cases. Like if you're interested in this actually in production, check out some of the Flyte talks we've had where people talk about their actual infrastructure and architecture of how they use this. That's one from LinkedIn. LinkedIn switched all of their large language model workflows to Flyte, and they talk about what that actually looks like internally to the company, which is very cool. All right, so I have a little extra thing that we can go through here, but I also want to make sure that people said they reran the workflow and it was running, but then they never said if it had an error again or what. But if you want to, that's kind of the end of the workshop where we went through. This is a lot where someone asked for the Slack link. It should be in the description, but I will also share it in the chat. And I created a, you could post it in a couple different channels there. I created a workshop channel. So let's see, workshops. I created a workshop channel. I posted it in the events channel called workshops. And if you want to put more details there, I can maybe help troubleshoot it for you. Also, even if I end the live stream, I can go look at it there and see what's going on as well. Because I know originally you said it might have been you not putting in the right Hugging Face ID. But again, we went through this pretty fast, so it might have been a lot to kind of consume if you've never built like pipelines before. But if you did go through and were able to run this, you built again, kind of state-of-the-art pipeline with a lot of the built-in features that people are looking for when they're implementing MLOps in production. Like you have the scalability, the infrastructure, the cost optimization, the versioning, these reliable different workflows that you can relaunch and collaborate with other people in there. Got it. Awesome. Cool. Ryan said was the ID and just trying to do the steps again. Yeah, no problem. I know, like, I've done that before too. The only thing you really should probably need to do is just running this one code cell again. That's right under this long one with all that code. You just update your ID there. And then again, this repo name can be anything you want. So again, what did people think? Fun, interesting. It sounds like some people had errors. Sorry about that. I guess that's also the part of development and trying to integrate other tools and stuff like that. You have to bring in like a different piece of information, and there's possibilities for errors. Which again, I've encountered the same one. So don't feel bad about it or anything like that. And if you've programmed before, you probably know errors are a big part of programming and feedback. It's when you don't get errors and something is wrong. That's when it's harder. Well, people are maybe kind of still rerunning through the steps. And if you want to give any feedback or other comments in chat, I'm going to try running this little Gradio app in here. Sometimes this works and sometimes it doesn't because Gradio is a little finicky to run in a notebook. And they just updated to Gradio 5. And so I haven't really fully tested this with Gradio 5. I know there's some changes, but this is going to essentially create a little application with a user interface that we can call our executions from the API, just like we did before. Where we create a function, executes a Flyte task. It's all the stuff we did before. It's just putting it into one place. And then we're creating a Gradio interface. And a Gradio is a library that's used for creating interfaces, often in the machine learning and data world, where you can kind of create a simple little function like this, and then it creates a UI. So here, let's see if this works. So like I said, Gradio just upgraded to Gradio 5, and I know they did some changes. So let's say I hated this movie. Submit. Let me see if that kicked off an execution. It did. Okay, so one of the things I think I remember in the changelog for Gradio is that by default, it doesn't have this, like, you just have this feedback, like, spinning box. Like, if you hit submit and it's waiting on something, it would show up there. I guess it doesn't do that by default. So it looks like nothing is happening. I'm sure you can re-enable it. And so I would, if I was actually deploying this somewhere, because right now I just submitted it something and it seems like nothing is happening and I would leave as a user. But it actually kicked off a job. And so we'll see if it works, unless they also broke something else in it. Let's see. I think it's succeeded. And yeah, we'll see if it returns, or again, the Gradio 5 might have broken something here. Oh, there we go. So it took a minute here, but I guess when you're returning HTML, at least now in Gradio 5, by default, it doesn't have that like feedback spinning box. But here it returned sentiment is negative, and we add a little HTML to make it look prettier, and it gave us the confidence score. So you have this whole little UI now that you can interact with your trained model that you have in Union, which is pretty cool. Nice. Awesome. Well, I still see some people here, and I know we've kind of gone to the end of the workshop here. And I know some people sounded like you were able to sign up and run through everything. I'm not sure how many other people did. Not too many people were talking in the chat today. But if you have any questions, let me know. I'll hang out for a little bit. I still see people here, so people are watching something. Cool. Someone said they'll follow up in Slack. Yeah, thank you. Yeah, and sorry if you got an error. Hopefully it's just the username. But if you have anything else you want to share in the Slack, that'll be better to debug it. I know someone else said like they had a download task failing, but it doesn't sound like that was the case for you, Ryan. So I'm not sure what happened there. But if you can get that trace back, which again, if you do get an error, we do make it really easy to get the traceback right in the UI, go to that failed task, go to show error, and then you can copy and paste this into Slack. Again, if people are just joining, and I'm going to end the stream here probably pretty soon, but you can sign up here. It sounds like an interesting writing issue. I'll take a look at it, and I'll ping engineering too, see if something's going on there. Like I did mention, serverless is in beta, so maybe you ran into an issue that we can fix before we come out of beta. I will take a screenshot of that too, though, so I can pass it on if you don't post in the Slack later. And yeah, I'll go have someone help me find out what's going on there. All right, though, I think Kieran too, if you want to ping on Slack, we can probably help you there. If not, I'm going to still have someone look into it if they can. But I'm going to wrap up the live stream and see if I can figure out what is going on. But thank you so much, everyone, for coming out. And hopefully some people were able to run this without any errors. And I'm going to dig in to see what potentially would be causing that on your side. All right. Thank you, everyone. I'll hit the end here, but connect with me on Slack or on LinkedIn. Slack if you want to troubleshoot anything or ask more questions about Flyte or Union. That's probably the best place for it. And with that, I'll see you all later.